Dean Velcara had administered the Prismatic Institute of Higher Learning for 47 years. The institution was renowned across 12 star systems for its rigorous academic standards, producing the galaxy's finest scientists, engineers, and scholars. Every species sent their best and brightest, all following the same proven educational methodology: memorization, repetition, and strict adherence to established knowledge. Then came Tyler Morrison, age 17, from Earth. The problems began immediately. Mr. Morrison, Professor Thexquin said during the first advanced physics lecture, his tentacles rigid with disapproval, you will find that successful students transcribe lectures verbatim. Your note-taking appears to consist of drawings. Tyler looked up from his datapad, which indeed showed several sketches with arrows and annotations. Oh, yeah. I'm a visual learner. Drawing the concepts helps me understand the relationships between. There is no visual learning, Thexquin interrupted. There is correct information absorption. You will memorize the material as presented. Tyler's hand shot up 5 minutes later. Yes, Mr. Morrison. Thexquin sighed. Why does the Kelvin field equation use this specific constant? It seems arbitrary. What if we? The equation has been validated for 3 centuries. We do not question established scientific principles, we learn them. But how do we know it's optimal if we never question? Detention, Mr. Morrison. By week 3, Tyler had accumulated 17 detentions and become a legend among the student body. Not because he was disruptive or disrespectful, but because he kept asking, why? Dean Velcara reviewed the complaints stacking up on her desk. Tyler had questioned the efficiency of the standard warp drive design, heresy to engineering department, suggested an alternative to the unified field theory, 3 professors filed formal protests, and worst of all, formed a study group where students taught each other instead of learning from authorized instructors. She summoned him to her office. Mr. Morrison, she began, her chromatophores displaying stern purple, you are disrupting centuries of educational tradition. I'm really not trying to, Tyler said earnestly. I just learn differently. On Earth, we're encouraged to question things, experiment, collaborate. That is the problem, Velcara said. Education is not about experimentation. It is about preserving and transmitting established knowledge. But what about discovering new knowledge? The question hung in the air like a challenge. New knowledge is discovered by certified researchers after decades of proper education, Velcara explained. Students learn. Experts discover. There is a proper order. That seems really inefficient, Tyler said. I mean, some of history's greatest discoveries on Earth were made by people asking basic questions that experts thought were settled. Velcara was about to respond when her assistant interrupted. Dean, the galactic examination results are available. She pulled them up, preparing to show Tyler why traditional methods were superior. Then she froze. Tyler Morrison, 127th percentile. That's impossible, she whispered. The test only goes to 100th percentile. Oh, the physics exam? Tyler said. Yeah, there was a bonus question about theoretical applications. I had some ideas about modifying the Kelvin field equation, so I worked out the math. Was that okay? Velcara stared at the analysis. Tyler's ideas had solved a 40-year-old problem in field mechanics. His approach was completely unconventional, building up from first principles rather than applying established formulas, but mathematically sound. How did you? She began. I just asked why the equation worked that way, then tested what would happen if we changed the constants. Ran some simulations. It's probably wrong, but it was fun to. It's not wrong, Velcara interrupted. Mr. Morrison, this solution is revolutionary. Word spread quickly. Within days, research teams were analyzing Tyler's work. Within weeks, other students were cautiously asking why in their own classes. And within months, something unprecedented happened. Professor Thexquin stood before Dean Velcara's desk, looking uncomfortable. "I would like to propose curriculum modifications. Several students have pointed out that my teaching methodology may be suboptimal." "Let me guess," Velcara said. "They're asking questions. Constantly. It's infuriating." He paused. "It's also producing better results. Students in Mr. Morrison's study group are outperforming traditional learners by significant margins." The revolution spread. Other professors began incorporating human learning methods, encouraging questions, promoting collaboration, allowing students to experiment with established theories. The Prismatic Institute's research output tripled within a year. But resistance remained. The Galactic Academic Council summoned Velcara to explain the chaos at her institution. "You're allowing students to question established knowledge," Council Chair Zixvara accused. "This undermines academic authority." "With respect, Chair Zixvara," Velcara replied, "we're producing better scientists. Our students aren't just memorizing, they're understanding. They're innovating. One human student has already contributed more to field theory than some researchers achieve in lifetimes. Because he refuses to follow proper methodology. Or because we've been following methodology that prioritizes conformity over curiosity." The council chamber erupted in argument. But the data was undeniable. Institutions that adopted human learning principles were seeing unprecedented breakthroughs. Tyler, oblivious to the controversy, continued his unorthodox education. He formed cross-species study groups. He encouraged classmates to challenge professors respectfully. He taught others his note-taking methods, his questioning strategies, his approach to problem-solving. "It's not that complicated," he told his study group one evening. "You don't have to accept things just because someone says they're true. Test them. Question them. If they're right, you'll understand why. If they're wrong, you just made a discovery." A Zentari student, Kiv Nash, who'd spent 8 years memorizing without understanding, suddenly grasped quantum mechanics after Tyler had him explain it using his own analogies. "I've been learning wrong my entire life," he said, stunned. "Not wrong," Tyler corrected. "Just differently. The galaxy's teaching methods work for preservation. Earth's methods work for innovation. Maybe you need both?" That simple observation became the foundation of educational reform across 17 systems. The Morrison method, combining rigorous knowledge transmission with active questioning and experimentation, was adopted by institution after institution. 5 years later, Dean Velcara stood at an educational summit, presenting their results. "We resisted because we feared chaos," she told the assembled academics. "But we've learned that questioning isn't disrespect, it's engagement. Collaboration isn't cheating, it's synergy. And curiosity isn't dangerous, it's the foundation of progress." She pulled up an image of Tyler, now a graduate researcher, working with a mixed-species team on faster-than-light theory. "One human student didn't just excel despite our system. He showed us that our system needed to evolve. Earth's greatest export isn't their technology or their resources. It's their refusal to accept because I said so, as a final answer." In the audience, former Professor Thexquin raised a tentacle. "But doesn't this create students who challenge authority?" Velcara smiled. "Yes. It creates students who think. Isn't that the point?" The summit ended with the Galactic Academic Council officially endorsing inquiry-based learning. Tyler's response when told about his impact was characteristically modest: "I just asked questions. Isn't that what schools are for?" Velcara updated her dean's log with a final note: "Human student asked why. Changed everything. Note to self, hire more humans."